Bismillahirrahmanirrahim. Global positioning system, Newton's and Einstein's view on gravity. Global positioning system. In global positioning system, geostationary satellites play a vital role in positioning the object on the surface of Earth. For example, if a geostationary satellite is able to view the objects on the surface of Earth in certain circular area, then two geostationary satellites can measure or can view some common, not all the objects on the surface of Earth, but there will be some less number of objects which are common to the two global positioning satellites. For example, initially we see that there are 5 cars which are under this area, but when we take the position of two common objects of two geostationary satellites, then there will be some converged area in which the objects will decrease. And by increasing the number of geostationary satellites, the common object will further reduce and we can locate a single object accurately. So if someone wants to find the position of a moving car, then geostationary satellite can give the position of one geostationary satellite can give the position of more than one cars, but in certain area. But by using the two, we will get a more precise result, and by increasing the number of geostationary satellites, the more precise, even better results will be available, and we will locate the position of a single car accurately. But what is the geostationary satellite? Let me explain it. An interesting and useful example of the geostationary orbit is Moon, or the geostationary satellite is Moon, whose orbital motion is synchronized with the Earth. It means for a person standing on the surface of Earth sees that Moon looks stationary almost. So Moon is an example of geostationary satellite. What should be the orbital radius of the geostationary satellite? The orbital rate to evaluate the geostationary satellite orbital radius are the time required to revolve in one satellite. We use the following phenomena. Following description, that we know that centripetal force keeps the geostationary satellite to move in a circle using the formula F is equal to mv square over r, and we know that this centripetal force is provided by the and we know that this centripetal force is provided by the pull of the Earth, which is a force of gravity or gravitational force calculated by this formula. And by comparing or equating the two terms, we get the velocity. And we know that velocity is always equal to distance over time. So velocity can be achieved, or speed of an object can be achieved by an alternate way. If you see the distance or the length of the circle covered by the geostationary satellite will be equal to 2 pi r. So speed can also be available by using this formula. Comparing these two formulas, we can get the radius, which is equal to 4.23 into 10 raised to power 4 kilometers. So A geostationary satellite is a satellite which rotates in an orbit of radius 4.23 into 10 to the power 4 kilometers. Communication satellites. A satellite can be set up by placing several geostationary satellites in orbit over different points on the surface of Earth. One such orbit covers 120 degrees of the longitude. 3 satellites can cover the whole Earth. Microwave are used for communication purposes. 200 Earth stations are still available on the Earth in which geostationary satellites move. Largest communication system is the Intelsat system managed by 126 countries. A single satellite can communicate 30,000 and 3 TV channel, 30,000 communications between the person and a channel, 30,000 communication channels can be there and 3 TV channels can be there. 30,000 voice channels. Newton and Einstein's view of gravity. Sir Isaac Newton described gravity as a force that attracts the things that have mass. His famous formula has been successfully used for hundreds of years to describe the orbit of the planet around the sun and the trajectories of the things like spacecraft. This formula is also used to calculate a person's weight on the given planet. And this formula is F is equal to G m1 m2 over r squared. Einstein's view of gravity. In his general theory of relativity, Einstein explained the forces of attraction between the massive objects in this way: that mass tells space-time how to curve, and the curvature of the space-time tells masses how to accelerate. Einstein's general theory of relativity predicted that the light paths should be affected by the massive objects. It means that if there is a heavy mass, then the light will not travel in a straight line near the heavy mass, but it will tilt and it will change the direction and it will move, the light will move in a curved path. For example, if light is coming from the sun to the earth, then the light actually changes its direction because of heavy mass in the near vicinity of the path of the light. Einstein's predictions were confirmed when the position of the star near the sun were observed to be shifted during the 1919 solar eclipse. Without solar eclipse and with solar eclipse, there are different positions of stars. It means that in the presence of heavy mass of the moon, the sun rays and the star light coming to the earth shifted their path. Because of that reason, the image of the stars look at different position. Here are 2 examples. Einstein's idea is that planets are merely following the curvature of space-time caused mostly by the mass of the sun and to a lesser degree the mass of the planets, and that no forces are involved in keeping the planets in their orbits. Einstein said that a person standing on the earth experiences an upward force in a direction pointing away from the center of the earth, and that the force is what keeps the person from traveling in his or her natural path, known as geodesy, through the curvature of the space-time. This curvature is caused mostly by the mass of the earth. Principle of equivalence is that if the stationary box stationary in the gravitational field, then it can fail, box failing freely it will be having the acceleration due to gravity. A box accelerate in empty space in no presence of gravitational pull or by the earth. How it accelerates? Actually, boxes move through the space at constant velocity, so it has an acceleration 0. Equivalence principle. Special relativity, all uniformly moving frames are equivalent and no acceleration. And if there is a gravitational field, then there is an acceleration. It means freely falling frames in gravitational field uniformly moving in general freely falling frames in general theory of relativity will be actually the uniformly moving frames in special theory of relativity. Thank you for watching the video. Please visit the website www.ncollege.com and please subscribe this channel for more informative videos and lectures from this college. Thank you.